All right, welcome to New 20 NEW. We are going to start factoring. We're going to start with the GCF, which stands for greatest common factor. You will hopefully see why we connected this with polynomials, all our work with polynomials, which was in the review section of this week. If you don't, I'll try my best to point it out to you. But ultimately, you may feel like all of it was kind of one big topic this week. Let's get started. All right, so factoring all goes together, but when you're factoring, you have to ask yourself, like, what type of factoring am I doing? And it won't all be the same. So each question is going to be different in that, just like everything else with math, the same process that you follow, or the process that you follow won't always be the same. You'll think, we're throwing a wrench into things, or that I'm throwing a wrench into things, or that I'm trying to make your life more complicated. And that's not really it. It's more just that you have to kind of look at the problem and decide what you're doing, because factoring is what they call the whole chapter, whereas factoring stands for 4 or 5 different things. So I'll try to break it up into the 4 different types of factoring there actually is, and I'll try to keep them separate for you and try to describe what the problems look like and when you use them, so that you can identify when to use them versus just calling it all factoring and calling it a day. So factoring with a GCF, this is the exact opposite of the basic distributive property with polynomials. So if you remember, and I'll kind of write it up here in this blank space, like when we did this, and I know you'll remember me saying to you, when you start with a binomial, you end with binomial. And we went like this, and then we got 3x squared minus 15x, right? And we drew, I even went so far as to draw like the 2 lines, right, as our in-between step. So we started here. This was our start, and this was our end. Now, this is our start, and we're going to want our end. So now this has become our start, and this is going to be our end. So now we have just hit the rewind button. When they do that, like in video editing, they just rewind it, and they play it like that, like special effect. That is what we've done. So this whole chapter is hitting the rewind button on polynomials. So we are starting with the finished binomial. And I mean, if you look at it, it even looks like it. I mean, I totally, pulled that one out of thin air, and it almost to the T looks like the ending one of the one, or the starting one of the one we're starting with on this worksheet. It has x squared, it has x. We are going to pull it back and basically pull the common factor out of it. Okay, so let's try it. Let's get started. If you were sitting around at the table with a couple of buddies of yours, and you all had, say, quarters. Say there's 3 of you, and one of you has 5 quarters. One of you has 4 quarters, and one of you has 3 quarters. Okay? and I say that I need to take quarters from you, but I can only take enough. I want to take the most from you, but I have to take an equal amount from each of you. Okay? How many could I take from all of you? Well, I can't take, I could take one from each of you, right? Let's say, I'm taking one. But I said I wanted to take the most that I could. Well, I could take another quarter from each of you, right? Now there's two. Oh, I said the one. I messed up, guys. See, these are all the things you would catch if you were in class. I said this person only had 3 quarters. All right, so now 5, 4, 3. And now I want to take the most. So I could take these 2 quarters from each of you. And now I could take this 3rd quarter from each of you. I can't go around again and take another quarter. Because while I could take it from this person and this person doesn't have another quarter to give to me. Right? He's out. This is almost like when you're playing cards and you're dealing, and now like you're out of cards, but you've already given the first two people a card and not like the last 2 people. The whole group that you're playing with does not have an equal amount of cards. So usually when that happens, like some games it says to put those cards, aside or in the pile or in the draw pile or whatever. So in this example with the quarters, I could take 3 from each of you. That would be the amount that I could take from everyone equally. I couldn't take 5. I couldn't take 4, because while I would be taking 5 from one of you, I would not be taking 5 from either of the other 2 people. I would not be taking 4 from the other 2 people. 3 is the amount of quarters that would be taken equally from all of you. Okay? So, the name of the game with GCF is exactly that. I need to take, with variables, the same amount from everyone in the most, right? I have to take the most from all of you in the most amount equally. And with the numbers, I have to take the greatest common factor, which if any of you remember from basic math, that's having to do again with like GCF, LCD, all that stuff. But basically, it's just the biggest number that goes into those 2 numbers. These numbers are going to be low enough that you don't have to do anything crazy. It's going to be a 2, it's going to be a 3, it's going to be a 6, maybe an 8. We like when it's a 10 because that's like an obvious number. Okay? But really, it's going to be the variable that's more important to notice. So let's try one out. The most important thing here is going to be the same idea from the review section of this week, that if you start with a binomial, you are going to end with a binomial. So I'm starting here with a binomial, which means I am going to end with a binomial. Now, out front, I'm going to put a line because I'm essentially dividing out, or I'm pulling out, a GCF. And that's whatever I'm getting from this binomial that is common between them, the terms. So 12 and 18. What divides into both 12 and 18? Well, they're both even, so that's a 2. But then I have to figure out if there's anything bigger. 3 divides into both of them. So if 2 divides into both of them and 3 divides into both of them, most likely 6 divides into both of them. And again, this is where that multiplication chart helps. And I'm going to upload that video after, because I'm writing down a list of all the things that it will help with this week, and I'm going to go over all of them, and I'm going to upload it. So 6 divides into both of them. So I'm going to put a 6 here. And I see that this one has 2 x's. And this one has 1x. So common between them, the most I can take from both of them is just an x. So now the name of the game is basically like working backwards. Like, how do I get from 6x? What do I multiply 6x by? What do I distribute in to get back to 12x squared plus 18x? Because I know the answer, if you think about it like that. If this is my answer, okay, and I have this 6x, what would I distribute this to the 6x? 6x times what? That would get me 12x squared. Well, 6 times 2 gets me 12. And x times what gets me x squared? X. And then 6 times what gets me 18. Plus 3, right? Because I needed a plus 18 or a positive 18. And then x times what gets me x. And it's okay to put nothing, right? It's okay, and again, we say nothing, but really it's a 1. X times 1, which we don't have to write anything. So 6x times just 3 gets me plus 18x. So we're done. That is my answer. 6x parentheses 2x plus 3 will give me 12x squared plus 18x. Let's look at number 2. So I am going to pull something out. If I'm starting with a binomial, I want to end with a binomial. So 8 and 30. So factors of 8. And again, if you really wanted to get, if you wanted to practice with the factors, 1 times 8, 2 times 4. My next one is 4 times 2, which is done because it's a repeat. 30, my factors of 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, 6 times 5. So I cross that one out because it's a repeat. The only one that is on that list that is seen on both of those lists is a 2. So that's how you know that 2 is your GCF. All right, now if there was one on that list that is, if there's more than one of those that is seen on both of those lists, you are looking for the greatest common factor, the GCF, so you would want to take the bigger one. So we want a 2 here. And again, these are going to become, repetitious as well, because if you see your variable situation is the same as in number 1. I have x squared here and I just have x here. So the biggest amount of x's I can take here is just an x. So 2x times what will get me back to 8x squared? It's going to be 4x. 2x times 4x gets me 8x squared. 2x times what? And again, I usually do signs, remember from my polynomials. I do signs, I do numbers, I do letters. Signs, number, coefficients, variables. So I need a negative in here. 2 times 15 will get me 30. And x times nothing will keep me at x. And that's my answer. All right, 16. 1 times 16, 2 times 8, 4 times 4. 24. I have 1 times 24, 2 times 12, 3 times 8, 4 times 6, 6 times 4. So I'm done. I have a binomial. So I'm going to end with binomial. What number do I see there? I see 2s. I see 4s. So 4 is where it's at. So I'm going to have a 4 here. This has 3 x's. This has 2 x's. So I can pull a 2. I can pull 2 x's out. So I have x squared here. So 4 times what gets me back to 16? That's going to be 4. X squared times what gets me to x to the third? That's going to be x. Because remember, I'm adding my exponents. If I have 2, how many more do I need to get that third one? Just 1 more. 1, 2, 3. And you can almost see it if I draw it out like that. I need a negative or a minus in there. 4 times what gets me back to 24. And if you draw it all out like this, you can almost see it because here's my 4, well, here's my 6. So I need a 6 there. X squared, well, I already have my 2 x's. I don't need anything else. There's nothing else there. So I need nothing else here. So I'm all done. The more visual you make for it, the better off you'll be. All right, 10, 25. So 1 times 10, 2 times 5, 1 times 25. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 times 5. Start with binomial. I'm going to end with binomial. The only difference is I have this thing out in front of it because I'm dividing it out. I'm pulling out. This is called my GCF. Okay, that is my GCF. All right, my common number here is the 5. I have x, 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 and I only have x, x here. So what's common between them? X squared. So 5x squared, what am I multiplying to get back to 10x to the third? A 2 and an x. I need a plus in the middle. 5 times 5 will get me back to 25. There it was. And there was my 2, right? So I see both of those. And then I have x squared. I want x squared, so I need nothing right here. So there is my answer. All right, let's go down to number 5. A little bit different, but let's see what happens. If we start with a trinomial, we are going to end with a trinomial. Now, I have 3, I have 9, and I have 15. So 3, my only factors are 1 and 3. 9, my factors are 1 and 9, 3 and 3. 15, my factors are 1 and 15, 3 and 5. So my only common number there throughout those 3 are 3. Now, if you look up here, I have 2 x's here, I have 1 x here, and I have no x there. Okay. One thing to note, if you lead with a negative, you want to pull the negative for your GCF. So if you lead with a negative, you want to pull your negative for your GCF. It will change all your signs to the opposite. Okay, so what do I mean by that? So let's do the problem and we will talk about what that means. So 3 is your number GCF. Can I pull an x out? Does everything have an x? Okay, no. This does not have an x. So I cannot pull an x out. And that's okay. That just means it's not part of your GCF. So when I do this, -3 times what will get me -3x squared? So it's going to be a positive x squared, right? Because I'll have, let's just write the answer down below, right, to check our work. Negative times a positive will get me a negative. I'll have a 3, and now I'll have an x squared. So I'm good so far, right? Okay. Here. -3 times what will get me -9x? Well, I need a positive, because I'm getting the negative from over here. 3 times what will get me 9? 3. What times x will get me x? An x. So negative times a positive will get me a negative. 3 times 3 will get me 9. Blank times x will get me blank. X, sorry. All right, -3 times what will get me positive 15? Negative 3 times what will get me 15? 5. So negative times negative will get me positive. 3 times 5 will get me 15. Did we get it to match? Yes. So if you look, negative becomes a positive, negative becomes a positive, positive becomes a negative. So if you lead with a negative, you want to pull your negative for your GCF, and it will change all your signs to the opposite. Okay, so we're going to see that happen again in number 8. So we'll save that. Okay. All right, let's look at this one. Again, trinomial. So if we start with a trinomial, we are going to end with a trinomial. Let's look at our GCF. So we have 4, we have 8, we have 12. So 4 is 1 times 4. 8 is 1 times 8 or 2 times 4. And 12 is 1 times 12, 2 times 6, 3 times 4. So I see, 4 is 2 times 2 as well. Sorry, I didn't catch that. So I see 2's, but I also see 4's. So because I'm looking for the GCF, I want it to be a 4. This one has an X and an X. This one has an X. This one has nothing. Because that one has nothing, no X's, no variables, I cannot put it as a part of my GCF. So I'm ready to go. 4 times what will get me 4x squared? X squared. 4 times what will get me negative 8x? Minus 2x. And 4 times what will get me positive 12? Positive 3. And I'm all done. All right, this one I'm just going to rewrite because it got a little bit messy with my writing. So I have 2x to the third minus 4x to the second plus 8x. So I have 2, I have 4, I have 8. All right, so my GCF for 2 is 1 times 2. My GCF for 4 is 1 times 4 or 2 times 2. My GCF, my factors. My factors for 8 is 1 times 8, 2 times 4. That's it. So looking for common ones. Looks like 2 is where it's at. Here I have 3 x's. Here I have 2 x's, and here I have an x. So out of the trinomials, this is the first time where I've had a common x, right? The other ones I did not have that x term on the last term, but this one I do. So I have a 2, and I have an x. So 2x times what will get me back to 2x to the third. So what do I need to add back in? So if we're using our visual pieces here, I need a 1, so I don't even need to write that. And then I need 2 more x's. So I need x squared. I could put a 1 there, right? So 2 times 1, and then x squared times x will get me 2x to the third. All right, 2x times what will get me negative 4x squared? Well, I definitely need a negative, so sign. Number, 2 times what will get me 4? That's a 2, and we see it right there. And then x times what will get me x squared? Well, I have one x, I need another x, so that's an x. And then I need a positive here. 2 times what will get me 8? That's 4. X times what will keep me at x? That's nothing. So that's my answer. All right, here we go on the last one. So I'm going to, I have a trinomial. I want a trinomial. And I'm leading with a negative. So I do want to pull my negative for the same reason as up here. Okay? That's just an etiquette thing. Now, if I'm looking for my factors, factors of 6 are 1 and 6, 2 and 3. Factors of 12, 1 and 12, 2 and 6, 3 and 4. Factors of 18, 1 and 18, 2 and 9, 3 and 6. So if I'm looking for common numbers, I have a 2, I have a 3, I have a 6. So I want the biggest one, so I want a 6. Now if I'm looking at x's, I have 3 x's here, I have 2 x's here, and I have an x here. If I'm looking for the most I can take from each thing, I can take 1. Because again, that last term is my limiting term. That only has 1 to take. I have to take an equal amount from each, from all of them. So that one only allows me to take 1 from all of them. So x there. So my GCF is negative 6x. So now I'm working backwards to try to get to my original problem. And I can use all this visual stuff to figure out what gets me there. Remembering that this negative is going to switch all my signs here. It's going to make them opposite here, here, and here. All right, so negative 6x, I want to multiply to get negative 6x to the third. So negative 6x times what will get me negative 6x to the third? Well, it's going to be positive. 6 times what gets me 6? That's going to be 1. Here it is. And x times what gets me x to the third? Here it is. X to the second. Negative 6x times what gets me negative 12x squared. Well, a negative times what will get me a negative? That's going to be a positive. 6 times what gets me 12? There it is, 2. 6 times 2 gets me 12. And x times what gets me x squared? X. And here's my last piece. I'm trying to get 18x, positive 18x. So a negative times a negative gets me a positive. 6 times 3 gets me 18. And I already have the x. I need an x. You see that here. So I don't multiply it by anything. So that's my answer. You'll notice with all of the worksheets from this week, 20, 21, and 22, there's an extra worksheet. It's called 20.5, 21.5, and 22.5. It is an extra. It's an extra independent practice because there's not eight topics like in the previous 2 weeks. It is an extra worksheet with an answer key if you guys would like to do it and you'd like to get more practice. So go ahead, try these, try some more, keep working at it, and let me know if you need any help.